On October 3, 2025, the interstellar comet 3I/ATLAS stunned astronomers as it passed near Mars. At that moment, the comet was roughly 29 million kilometers away from the red planet, close enough for multiple space agencies to track it in detail. Its speed was extraordinary, moving at nearly 219,000 kilometers per hour, making it one of the fastest moving objects ever observed in our solar neighborhood. In this video, we'll explore the claims that 3I/ATLAS fired an intense beam of light toward Mars, what the data really shows, and why scientists believe this could be one of the most mysterious events in recent space history. And before we dive deeper, make sure to subscribe and turn on notifications so you don't miss any of our investigations into the strangest discoveries the universe has to offer. Long before the shocking reports of a strange beam of light, 3I/ATLAS had already captured the attention of astronomers around the world. What makes this object so unusual is that it isn't just another comet from our solar system. 3I/ATLAS is classified as an interstellar comet, meaning it comes from beyond the boundaries of our solar system. Unlike ordinary comets that orbit the sun in repeating cycles, interstellar objects are travelers from distant star systems, passing through once and then disappearing back into the dark. The first time scientists detected 3I/ATLAS was in late 2024 when the Asteroid Terrestrial Impact Last Alert System, or ATLAS, spotted a faint, fast-moving object on its wide-field telescopes. Its speed and trajectory immediately told researchers this was no ordinary discovery. With a velocity exceeding 219,000 kilometers per hour, it was clear this object was moving far too quickly to be bound by the sun's gravity. Just like its famous predecessor, Oumuamua in 2017 and 2I/Borisov in 2019, 3I/Atlas was a rare visitor from the depths of interstellar space. What made 3I/ATLAS especially interesting is its composition and brightness. Early data suggested it carried massive amounts of volatile material, giving it a brighter and more dramatic coma than most comets. As it drew closer to the inner solar system in 2025, astronomers prepared their best instruments to capture every detail. Mars became the perfect observation platform, with orbiters and landers positioned to monitor the comet's approach at a distance of about 29 million kilometers. For planetary scientists, this was an unprecedented chance to see how an interstellar traveler behaved near one of our neighboring planets. But then came the reports that would ignite worldwide attention. Instruments appeared to detect a sudden, powerful flash directed toward Mars, something described as an intense beam of light. Whether this was a natural outburst of gas and dust or something far more mysterious, nobody could say for certain. What was once a simple astronomical observation had now become the center of one of the strangest debates in modern space science. And that leads us directly into the next part of our journey, the event itself. What exactly was this so-called beam of light? How was it recorded, and why did it appear to target Mars so precisely? Let's break down the details of the phenomenon. As 3I/ATLAS drew closer to Mars in early October 2025, multiple observatories and space probes reported an extraordinary phenomenon. Sensors recorded a sudden, concentrated emission of light originating from the comet, directed toward the red planet. While the exact mechanism is still under investigation, preliminary measurements suggest that the beam lasted for just under 45 seconds, yet it was powerful enough to register across several instruments simultaneously, including high-resolution cameras on Mars orbiters. Experts were initially cautious. Could this be a misreading of natural outgassing or reflections from the comet's icy surface? Comets often release jets of gas and dust when heated by the sun, and these jets can sometimes appear as flashes of light. However, what made this event different was its unusual concentration and apparent directionality. Unlike typical comet outbursts, which spread material in multiple directions, this emission seemed focused, almost as if aimed. Astronomers analyzed data from multiple sources: the Mars Reconnaissance Orbiter, MAVEN, and Earth-based telescopes. The brightness of the light, its sudden appearance, and the narrow trajectory left many researchers baffled. Some speculated that it was simply a rare natural phenomenon, a high-energy ejection of gas triggered by internal pressure changes within the comet. Others considered the possibility of charged particles interacting with solar winds in a way rarely seen before. Regardless of the explanation, the beam became the focal point of global attention, fueling discussions about the mysteries of interstellar objects. The timing was precise. At the moment of the emission, 3I/ATLAS was moving at nearly 219,000 kilometers per hour, and Mars was about 29 million kilometers away, creating a scenario that combined extreme speed, distance, and unexpected intensity. It was the kind of event that professional astronomers dream about, but few ever witness, a fleeting yet undeniable cosmic spectacle. Understanding what caused this beam is critical, because it sets the stage for interpreting not just 3I/ATLAS, but the behavior of all interstellar visitors we may encounter in the future. Scientists continue to study the phenomenon, using computer models and spectroscopic analysis to determine the energy released and the composition of the material involved. This brings us to the next question. What do the scientists think about this event? Are there plausible explanations rooted in physics? Or is there a chance that something entirely unknown is at play? Let's dive into the scientific theories and analyses surrounding this mysterious beam. The sudden, focused beam of light from 3I/ATLAS immediately sparked questions in the scientific community. What could possibly produce such a phenomenon? And is there a natural explanation? Scientists have proposed several theories, each grounded in the physics of comets, interstellar travel, and solar interactions. The most widely considered explanation is a natural outburst caused by volatile gases and ice sublimation. As comets approach the inner solar system, the sun's heat causes frozen materials inside them to vaporize rapidly. This can result in powerful jets of gas and dust shooting out from the comet's surface. In rare cases, these jets can align in a narrow direction, creating a bright flash that might appear beam-like from a distance. In the case of 3I/ATLAS, researchers calculated that the energy released could have reached several terajoules, enough to produce the brief, intense light recorded by Mars orbiters. Another possibility involves solar-wind interactions. Comets are electrically charged bodies, and when high-speed particles from the sun collide with their surfaces, they can trigger sudden bursts of energy. This phenomenon, though rare, has been observed in some highly active comets within our own solar system. Such an interaction could explain the intensity and narrow focus of the light without invoking anything beyond standard physics. Finally, some scientists are exploring the more speculative idea that we might be witnessing a previously unknown interstellar phenomenon. Interstellar comets like 3I/ATLAS may have compositions or internal structures unlike any objects native to our solar system. The sudden beam could represent a form of energy release that is extremely rare, perhaps linked to the unique way interstellar objects store and release energy after traveling through the cold void of space for millions of years. While natural explanations remain the most likely, researchers emphasize that the event challenges our understanding of comet behavior. Observations are still being analyzed, with teams cross-referencing data from telescopes, spectrometers, and orbital instruments to reconstruct exactly how and why the beam occurred. This scientific inquiry naturally leads to the next question: how did this beam, whatever its cause, relate specifically to Mars? Could such an event have had measurable effects on the planet, or was it purely a distant spectacle for our instruments to record? Let's explore the Mars connection next. As 3I/ATLAS approached the inner solar system, its trajectory brought it within 29 million kilometers of Mars, close enough for instruments aboard orbiters and rovers to detect even subtle phenomena. When reports surfaced of the so-called beam of light, scientists immediately turned their attention to Mars. Could this emission have actually interacted with the planet, or was it simply a distant spectacle? Data from the Mars Reconnaissance Orbiter and MAVEN spacecraft revealed something startling. While the beam did not physically strike the surface, sensors detected brief disturbances in Mars' upper atmosphere at the exact moment the emission was recorded. These disturbances were subtle, a slight spike in ionized particles and temporary fluctuations in magnetic field readings. Yet their timing was uncanny. The planet's atmosphere, normally calm in that region, seemed to respond as if the comet's energy had grazed it. Rovers on the surface, including Perseverance, did not register direct impacts, but orbital imaging captured a faint, transient glow in Mars' thin upper atmosphere. It lasted mere seconds, almost like the planet had blinked in response to the beam. Scientists describe this as both rare and unnerving. Never before has a comet, let alone an interstellar visitor, caused a measurable reaction in a planet's atmosphere without actually colliding. The implications are profound. Was this a natural interaction between cometary emissions and Martian atmospheric particles? Or could there be something more mysterious at play? Some form of energy release we do not yet understand? The timing, intensity, and focus of the beam, combined with the subtle atmospheric response, suggests that 3I/ATLAS may have momentarily communicated with Mars in a way that defies simple explanation. This is the moment where reality blurs with speculation. While the most likely explanations remain rooted in physics, the precise alignment and energy observed leave space for wonder, and perhaps for a deeper cosmic mystery. And now, with Mars' response recorded and scientists scratching their heads, the question becomes even more urgent. What does this all mean for our understanding of interstellar objects? And could this event hint at phenomena we have never encountered before? Let's explore the bigger picture and the theories that might explain one of the strangest cosmic events in recent memory. With 3I/ATLAS now behind Mars and continuing its journey out of the inner solar system, scientists and enthusiasts alike are left with more questions than answers. What we witnessed was not just a passing comet, but a rare interstellar traveler capable of producing an unprecedented phenomenon, a brief, focused beam of light that seemingly interacted with a planet millions of kilometers away. From a scientific standpoint, the event challenges our understanding of interstellar objects. Comets from beyond our solar system are already unusual, often carrying material that hasn't been exposed to the sun for billions of years. The sudden emission and its apparent directionality suggests that there may be processes in these objects that we have never observed. Extreme energy releases, volatile reactions, or even unknown particle interactions that push the limits of our current models. Speculative theories, while unproven, have naturally captured public imagination. Could this have been a natural signal, a way the comet's internal energy expressed itself in a concentrated burst? Or is it possible that interstellar objects like 3I/ATLAS could carry forms of energy or structures entirely alien to our solar system, the kind that might look deliberate, almost aimed to our instruments. While there is no concrete evidence for advanced technology, the precision and intensity of the beam remain a cosmic puzzle. What is certain is that events like this remind us how little we truly know about the universe. Each new interstellar visitor is a message in motion, offering clues about distant star systems, the building blocks of planets, and the potential for phenomena that we have yet to classify. 3I/ATLAS has shown us that even a single comet can produce effects that ripple across millions of kilometers, sparking debates, inspiring research, and igniting wonder. As we continue to analyze the data, one thing is clear: this event is a turning point for planetary science and the study of interstellar objects. What we learn from 3I/ATLAS may not only change how we understand comets, but could redefine our expectations for every interstellar traveler that passes through our solar system in the future. If you found this journey into the unknown fascinating, make sure to subscribe and turn on notifications. We'll continue to bring you the latest discoveries, cosmic mysteries, and the stories that challenge what we think we know about the universe. The cosmos is full of surprises, and 3I/ATLAS is just the beginning.